Before the Human Genome Project was even being contemplated, three scientists, Rosalind Roosevelt, Francis Crick, and James Watson, discovered the double helix structure of DNA we use today. This discovery led to be a difficult barrier to break in 1953 because of how unsophisticated technology was, and scientists researching DNA didn't have a lot to work with. However, they pulled through, leading the future genetic scientists to wonder, what is the sequence of the human genome? A cell, one of the trillion in your body, is an organism that contains the 23 chromosomes of your genetic code. A chromosome is an H-shaped structure consisting of DNA wound up in tight strands. These strands of DNA, unraveled and divided into separate pieces, are genes, which hold pairs of letters that make up your genetic code. Your genetic code is a list of products you need to produce proteins. Proteins are one of the most important microorganisms you'll find in your body. Proteins send messages to organs in your body, like your muscles or brain. These orders make your body function properly. Proteins also provide needed nutrition for a healthy body. Some proteins you can only get from certain foods, but most of them are made from your genetic code. When a genetic code is faulty or non-existent, proteins are not produced properly, and the result can be things like a heart not beating or muscles not functioning properly, also known as Parkinson's disease. Another disorder faulty genes can cause is cancer. Cancer kills thousands of people per day. The Human Genome Project was a race to sequence the 3 billion letters of genetic code stored within the 23 chromosomes in a human cell. This work took over 10 years, but had encouraging results. Scientists hope to break this barrier of new and profound knowledge to find cures to many genetic disorders and save lives. After Crick and Watson's discovery of the structure of the human genome, scientists were determined to map the human genome. They started mapping the human genome in 1990. Scientists from all over the world joined in. Though scientists were eager to start unraveling information, they knew the difficulty of breaking this barrier. One of the major setbacks to this project was the fact that it was big science. Finally, in 1990, scientists began mapping the human genome using $3 billion of tax funds and preparing for a long 15 years. About 7 years into the project, a private company with the name of Celera announced that they could map the human genome in 3 years and at a fraction of the cost. The Human Genome Project and Celera both had the same goals, but they were different in many ways. While Celera was a private company that didn't have to share any of its discoveries with the world, the Human Genome Project was managed by the government and had a 24-hour publish rule, which meant that whatever they recently discovered had to be published to the public in less than 24 hours.
We are here to celebrate the completion of the first survey of the entire human genome. Without a doubt, this is the most important, most wondrous map ever produced by humankind. It was not even 50 years ago that a young Englishman named Crick and a brash, even younger American named Watson first discovered the elegant structure of our genetic code. Today's announcement represents more than just an epoch-making triumph of science and reason. After all, when Galileo discovered he could use the tools of mathematics and mechanics to understand the motion of celestial bodies, he felt, in the words of one eminent researcher, that he had learned the language in which God created the universe. Today we are learning the language in which God created life. With this profound new knowledge, humankind is on the verge of gaining immense new power to heal. Genome science will have a real impact on all our lives, and even more, on the lives of our children. It will revolutionize the diagnosis, prevention, and treatment of most, if not all, human diseases. In coming years, doctors increasingly will be able to cure diseases like Alzheimer's, Parkinson's, diabetes, and cancer by attacking their genetic roots. The robust and healthy competition that has led us to this day, and that always is essential to the progress of science, will be coupled with enhanced public-private cooperation. Public and private research teams are committed to publishing their genomic data simultaneously later this year. Together they will examine what scientific insights have been gleaned from both efforts and how we can most judiciously proceed toward the next majestic
While
horizon.
Celera and the Human Genome Project first discussed teaming up, they quickly decided against the idea because of ethical and legal social implications, which Celera were against.
With
Ethical and Legal Social Implications Program, also known as ELSI. The ELSI program was a program created by the Human Genome Project in 1990 that did a number of things to help protect privacy. The mission of the ELSI program was to address issues raised by genomic research that would affect individuals, families, and society.
The Human Genome Project and Celera continued to race against the clock to complete the map of the human genome. In 2001, they were just about at the same point, 90% complete. Bill Clinton gave a speech announcing the company's great discovery to the world. Millions of disabled and sick people gained new hope, and at last, in 2003, barriers finally broke. Both companies had successfully completed the map of the human genome, enabling researchers to diagnose and treat thousands of new genetic diseases.
Diagnosing and treating diseases is not the only benefit of mapping the human genome. New technologies have been developed to map genomes in only a day or two. Genetic codes is also given information on how the human body is built. One of the most important events that the Human Genome Project influenced occurred back when the mapping was just beginning.
The September of 1990, right after the Human Genome Project's launch, a man named Dr. W. French Anderson performed the first gene therapy on 2 young children. This event took 2 years and it was successful.
Gene therapy is a procedure where new DNA is inserted into your genes when a faulty one is causing problems. Once the gene is inserted correctly, it should function properly and produce new proteins.
However, this process is expensive and has a low success rate. Not much is done with it now, but in the future, a new generation of scientists could break barriers of inconsistency, and gene therapy isn't the only possible solution.